Okay, let's talk about the some dosage forms which are very important for us. In pharmaceutical industry, the basic thing is free formulations and also this so many things are there. Basic things like why we have to develop a dosage form. Though so many things are there. So like why what is the importance of pharmaceutics? Only I'm focusing on the pharmaceutics. So, if you take example of dosage forms, there are injections, solutions. In that injection, solution, suspensions. So, solid dosage form, liquid dosage forms, and semi-solid dosage forms like that. In that injections, like parental dosage forms, like injections, in the injection suspensions, solutions. So, first thing when you're doing any particulate system, intravenous solutions only you can inject to the veins. So, IV dosage form, so intravenous. So, if you do a dosage form in intravenous, there should be a solution. There should be any particulate matter. Usually, if you compare with the suspensions, emulsion, those kind you can't inject into the where in intravenous because what happens is it will block the capillaries. So particles are around 5 to 10 micron in the suspensions which you inject in the muscular dosage form, it form a depot formation. In tablets, what happens? It will, if you inject it, we ingest it and it will go to stomach. It have absorption phase, then it has rate limiting step is absorption. But intravenous system does not have any rate limiting system. It is 100% available because instantly it will be available. So IV system and IM system is totally different. IM system is usually created for sustained release dosage forms. So it make a depot formation. That's the reason it will be sustained release. So solution, suppose suspended particles are with that which is in a 5 to 1 micron or 5 to 10 micron. So that particles what you will do inject as an IM, it forms a depot. So it forms a depot. This depot will make a sustained release. Okay, when depot forms sustained release, what happens? It will keep on releasing sustained and it will be more extended period of time. So subcutaneous, intramuscular, there are a lot of other forms which are available in this like this, and there are some people are making microparticles. So and gels, instead of gels they are forming. So these kind of systems are there. So why I'm explaining is first I'm going to tell about solid dosage forms, and then liquid dosage forms, then semi-solid dosage forms, and also the other kind of dosage forms which are very important for our pharmaceutical industry. In industry wise, very important thing is impurities. So in academic we won't see any impurities. So impurities are the very headache for the pharmaceutical industry. Especially we have to optimize our process to reduce the impurities. So FDA says strictly that you can't say that my impurity levels whatever it is I can place. No, it's not possible. You have to control these impurities. Suppose for instance I will say that 0.10 for which you don't know the structure anything which is unknown, but it is coming in your, but no need to qualify anything, it is in the middle quantification limit. So FDA concerned about toxicity of these impurities. So now you understood that very importance of impurities and the guidelines also there, ICH guideline. So generally if you have more suppose you are injecting more than 5 gram or 10 gram or something, the limits are there. Suppose 2 gram to like that. If you're ingesting more means the limit will be less, it will be more less. Understand? And if the impurities you are getting and you don't know that impurity, then you have to qualify it. That is for sure. And you have to qualify and you should show that it is not at all a toxic. So innovator is getting same in higher level means you can justify with that. But unknown which is you are getting and RLD means innovator not getting means you have to be very sure that that impurity must be qualified and you should do genotoxic studies. Qualification means doesn't mean you have to identify the structure as well as you have to do the toxicology studies. So you have to know the toxicity of that impurity. This is very important. And one more thing is nitrosamines which are recently impurity related. So nitrosamines are which are related to not at all, sometimes not at all related to the product. Sometimes it is generated in the product because of combination of excipients and drug product. So sometimes what will happen if you do the heating, thermal process, then also the impurity will be generated. So I am just concising this pharma. So this will be the where the perspective you will get some lot of questions. We will make a 5 minutes video and we will discuss this daily basis. So please subscribe and like my videos and keep on I will giving these videos for you. Bye.